Like I was saying, this is the butterfly operation for decimation in time fast Fourier transform. Okay, for which we'll be having the set of inputs from which outputs will be calculated. If we denote the outputs as capital A and capital B, the top point of this butterfly operation will be A, one of the input, plus this critical factor WNR multiplied by the second input WNR into B. And the bottom point of this butterfly operation, capital B, will be A. Because of this minus 1, it will be minus WNR into B. Because at this point there is a product B into WNR. This product will be subtracted from A. That will be the bottom point. Now, if you observe the signal flow graph of decimation in time fast Fourier transform, in every stage will be having n by 2 number of butterflies for n point DFT, and likewise will be having v number of stages. Likewise, we'll be having v number of stages, which will be defined as log n to the base 2. Log n to the base 2, or we can represent capital N as 2 to the power b as well. Okay, so capital V represents the number of stages. Number of stages to obtain n point DFT. Number of stages in the decimation in time fast Fourier transform to compute n point DFT. Okay, and each stage will be having n divided by 2 number of butterfly operations. So we will be having n by 2 such butterfly operations in the each stage. But depending on the decimation, the structure of these butterfly will be different. In the first case, all 4 of these butterfly operations will be individual. In the second case, 2 of them will be overlapped to get the appropriate outputs. Okay. Now, those structure we had seen in the previous class. Now, based on the concepts that we studied in the previous class, let us solve some problems. Let us try to implement the DIT-FFT algorithm to compute an 8-point DFT. So, discrete time sequence is given by x of n equals to 1 1 1 1 0 0 0 0. So, capital N number of samples in this discrete time is equal to 8. Capital N is equal to 8. Okay. So, for capital N equals to 8, how many number of decimation stages will we having, or how many number of times do we need to divide this sequence? Divide this sequence into even number of samples and odd number of samples. Then further, there will be n by 2 point sequences which has only even samples and odd samples from x of n will be further decomposed into 2-point sequences. Okay. Now, how do we understand all that? For capital N equals to 8, or n can be represented as power of 2 as 2 to the power 3 to get n equals to 8. That means V is equal to 3. Capital V is equal to 3. Capital V represents the number of stages in the signal flow graph. We had 3 stages for n equals to 8 in the previous diagram what we had drawn. V equals to 3, V equals to 1, and V equals to 2. 3 stages in the signal flow graph. Okay. Now, to compute 8-point DFT, we'll be having 3 stages in the signal flow graph, and how many decimations are to be performed on this discrete time sequence? That will be given by V minus 1, that is 3 minus 1, 2. 2 decimations. Now, these 2 decimations, because first, 8-point sequence will be divided into 2 4-point sequences. Later, this is one decimation. One 8-point sequence is divided into 2 4-point sequences, first decimation. In the second decimation, 2 4-point sequences will be divided into 4 2-point sequences. This is the second decimation. Okay, so we'll be having 3 stages, V equals to 3, and V minus 1 number of decimations that are being performed. And along with this, now to develop the signal flow graph, we will be needing these. twiddle factor values. For n equals to 8, we'll be using n by 2 number of twiddle factors. N by 2 number of twiddle factors. And those twiddle factors are W80. And the value for W80 is 1. Now this W80 is equal to W40, whose value is also 1 for 4-point DFT in the second stage of decimation. And this is equal to W20. Now W20 will be used for 2-point DFT calculation in the first stage. Okay. Next, twiddle factor will be required is W81, which is 0.707 minus J 0.707, or 1 by root 2 minus J 1 by root 2. The next twiddle factor that will be needed is W82, whose value is minus J. Now this minus J will be used to compute 4-point DFT as well, and its equivalent value for 4-point DFT is W41. Okay, likewise. The last twiddle factor that will be required is W83, whose value is minus 0.707 minus J 0.707. These twiddle factors. Now this is the information of the signal flow graph that will be developing. Attack today. Are you all following? Are you all following? Okay. Now let's start developing the signal flow graph. We'll begin from the input side. Because the algorithm is decimation in time fast Fourier transform, to compute DFT, input sequence is a discrete time sequence. So that time domain sequence has to be decimated. Decimated means time domain sequence will be or should be in the bit reversed form. Okay. And the first index in the bit reversed form will be x of 0. First index in the bit reversed form will be x of 0. Now the for n equals to 8, the index value, its binary representation, bit reversal of that binary representation, and its equivalent integer values we had written in the previous class. Now, according to that bit reversal, inputs will be applied to this algorithm. So, first index will be x of 0. X of 0's value is 1 in the given sequence. Now, if you want, you can write the index values on top of this for your convenience. There are 8 number of samples. Index will be starting from 0 to 7. Next index value, according to the bit reversal, will be x of 4. And x of 4's value in the given sequence is 0. Next index value will be x of 2, whose value is 1 in the given sequence. Next will be x of 6, whose value is 0. Next, x of x of 1. X of 1, whose index value is 1. X of 5, whose index value is 0. Next two are x of 3, whose index value is 1. And lastly, x of 7, whose index value is 0. Now, in this order, in this bit reversed order, inputs will be applied to decimation in time fast Fourier transform algorithm. So, these are the inputs. In this way, the inputs will be applied to the first stage of decimation. Or if we come backwards, this will be the last stage of decimation, where 8-point sequence was divided into two 4-point sequences and their 4-point DFTs were calculated. Then 4-point sequence were divided into 2-point sequences. These are those 2-point sequences, for which we need to calculate 2-point DFT. Okay, so let us draw the third stage of decimation. Now, if you observe the signal flow graph, in the wherever you perform decimation, on that side we'll be having individual butterfly operations. So in the last stage of decimation, the butterfly structures that we had drawn was something like this. W80. Actually, here it has to be W20, but to save the or to have the constraint, because of the constraint on memory locations, will not be calculating this separately, W20. Its equivalent value, W80, will be used. So W80. Now next butterfly structure, -1, W80. Third butterfly structure, -1, W80. And the last butterfly structure, -1, W80. Okay. And what notations did we use on the other side? Output of this third stage of decimation will be 2-point DFTs. And the notations used for 2-point DFTs were V11 of K, where K will be taking only two values for K equals to 0 and K equals to 1. Likewise, V12 of K, V21 of K, and V22 of K. Now, these are the 4 2-point DFTs that are calculated for these 4 2-point sequences. Okay. Now, let us write them before we calculate V11 of 0, V11 of 1, first 2-point DFT. V12 of 0, V12 of 1, second 2-point DFT, V21 of 0, V21 of 1, third 2-point DFT, and lastly V22 of 0, V22 of 1, the last 2-point DFT. Now these values are calculated based on this equation itself. Capital A will be A plus WNR into B, and capital B will be A minus WNR into B. Now these are the two generalized equations. Based on this, the upper point in the butterfly structure and lower point in the butterfly structure will be calculated. For example, V11 of 0 will be x of 0 plus W80 multiplied by x of 4. Okay, because at this point, to calculate V11 of 0, one signal is coming from x of 0. Second data point is x of 4, but x of 4 is multiplied by W80. And to calculate V11 of 1, instead of addition, because of this -1, it has to be subtracted. Okay, now let us substitute the values. V11 of 0 is equal to x of 0 is 1 plus W80 value is 1 and x of 4 in the given sequence is 0. So 1 into 0. 1 plus 0, 1. So first DFT point in the 2-point DFT sequence will be equals to 1, which is obtained by using this equation for the top point of butterfly operation. Now for the bottom point, that is V11 of 1, the expression will be x of 0, because of this -1 will be multiplied to this product, that is W80 multiplied by x of 4. W80 multiplied by x of 4. And if you substitute the values, V11 of 1, x of 0 is 1 minus 1 into 0, which will again be equals to 1. So second DFT point in the 2-point DFT is also 1. ಅರ್ಥ ಆಗ್ತಿದೆ? Are you all following? Okay. Now this has to be repeated. This has to be repeated for all the 2-point DFTs. And whenever you draw the signal flow graph, for every stage computation might be easy. Just by reading the values, you might get to know what is the DFT at the other end. But compulsorily, you need to write these intermediate steps. Okay? So likewise, for V12 of 0, it will be x of 2 plus W80 x of 6. And likewise, for V12 of 1, it will be x of 2 minus W80 x of 6. So values will be 1 plus 1 into 0, which will be equals to 1. And the second one, for V12 of 1, it will be 1 minus 1 into 0, which will again be equals to 1. So the second DFT, second 2-point DFT are again 1. And the same thing applies for the remaining two. That is V21 of 0, which will be x of 1 plus W80 x of 5. X of 1 is 1, x of 5 is 0. So again this point will be equal to 1. V21 of 1. V21 of 1 will be x of 1 minus W80 x of 5. Substitute the values, it will be 1 minus 0. So second DFT point here will be 1 again. And likewise, the remaining two inputs are same. We'll be using the same expression. So all 4 2-point DFTs are 1 1 1 1. Okay. So this is the output, or this is the 2-point DFTs. These are the 2-point DFTs obtained from 2-point sequence in the third decimation stage. Are you all following? Okay. Now, in the next stage of decimation, or in the next stage of the signal flow graph, these 2-point DFTs will be combined to obtain 4-point DFT. Now, let us draw those structures. In the second stage of the signal flow graph, these two butterfly structures will be overlapped here, they will be combined, and these two butterfly structures will be combined here. Okay? So, let us represent it. This will be first query factor. For the first butterfly structure will be W80, and the second butterfly structure will be Elaine verbatim. Because we are using we are calculating 4-point DFT, the middle factor seems will be W40 and W41. W40's equivalent value for 8-point middle factor is W80. We have used it. But W41's equivalent value for 8-point middle factor is W82. So here it will be W82. It will not be W81. There it will be W41, whose equivalent value will be W81. W82, which will be minus J. Now, while writing the signal flow graphs, you should be very careful with all the minute details. So, the same structure will be repeated at the bottom as well. This one, W80 and W82. And the notations used to represent the 4-point DFT were capital F1 of 0, F1 of 1, F1 of 2, F1 of 3, F2 of 0, F2 of 1, F2 of 2, and F2 of 3. Okay. We'll have to calculate these values. And say, to calculate F1 of 0, we have a signal coming from V11 of 0, and another signal is coming from V12 of 0, but V12 of 0 is multiplied by the middle factor W80. So plus W80 multiplied by V12 of 0. Value of V11 of 0 is 1, value of W80 is 1 multiplied by value of V12 of 0 is 1, which will be equals to 1 plus 1, 2. So first DFT in the first 4-point DFT sequence is 2. And to calculate F1 of 1, this is again, this is not the bottom point now. This is the top point of the second butterfly structure here. So its equation will be V11 of 1 itself, because one signal is coming from there, and another data point is V12 of 1. We have an upper arrow mark pointing upwards here to this point. So it will be V12 of 1 but multiplied by W82. So V11 of 1 plus W82 V12 of 1. Value of V11 of 1 is 1 plus value of W82 is minus j multiplied by value of V12 of 1, which is 1. So simplify this, you will get 1 minus j. 1 minus j. So 1 minus j is the second DFT point in the 4-point DFT sequence. Likewise, F1 of 2. So to calculate the third DFT point, observe here, this is the bottom point in the first butterfly operation in this stage. So its value will be taken by subtracting V11 of 0. Because of this minus 1, we will be having W80 V12 of 0. V12 of 0. V11 of 1 is 1 minus 1 into 1. 1 minus 1 will be 0. So this DFT point will be 0. This DFT point will be 0. And lastly, F1 of 3. F1 of 3 is the bottom point of the second butterfly structure. So it will be V11 of 1 minus W82 V12 of 1. V11 of 1 is 1 minus W82 is minus j. So it will be minus of minus j multiplied by V12 of 1, which is equal to 1. So this will be minus of minus will be plus, 1 multiplied by j will be j. So the last DFT point will be 1 plus j. Last DFT point will be 1 plus j. Did you all understand this? Yes or no? Okay. Now if you observe, this is the 4-point DFT and it has all the properties of DFT sequence. First is the DC value. Because of 4-point DFT, the second value and the last value are conjugate of each other. One value is 1 minus j and the second last value is 1 plus j, which is conjugate of 1 minus j. Okay. So likewise, here we need to repeat these equations to calculate F2 of 0. But for the input of this sequence is also same 1 1 1 1. So the DFTs will be same as that, like the first 4-point DFT. So I will be writing them directly, but you need to write these equations for F2 of k and then write the values. 2 1 minus j 0 1 plus j. So at the end of second stage, these are the two 4-point DFTs which are obtained by combining two 2-point DFTs or 4 2-point DFTs. In the last stage, these two 4-point DFTs will be combined to obtain one 8-point DFT. Okay. Now let us draw the butterfly structures. And in the last stage, all the butterfly structures will be all combined. Okay. So F1 of 0 will be connected to F2 of 0 and likewise. F2 of 0 will be going back to F1 of 0. And the 20 factors here will be W80, W81, W82, and W83. Now, what has to be the output here? Output A and B2? What should be the output? Input to this stage is two 4-point DFTs. So, output should be one 8-point DFT, which we are calculating. And that 8-point DFT, will it be in the bit reversed order or natural order? Will the output here be in the bit reversed form or natural order? It should be in the natural order because input was in the bit reversed form. So first DFT point will be x of 0, next will be x of 1, next will be x of 2, next x of 3, x of 4, x of 5, x of 6, and last DFT value x of 7. Okay, we need to calculate that. We'll write the equations for each of them. Okay, now to calculate x of 0, because it is the upper point in the first butterfly structure, we'll be having f1 of 0 plus w80 multiplied by f2 of 0. f1 of 0 is 2, w80 is 1, f2 of 0 is 2. 2 plus 2, 4. First DFT value in the 8-point DFT sequence is 4. Next, x of 1. To calculate x of 1, it is the top point in the second butterfly structure. So it will be f1 of 1 plus w81 multiplied by f2 of 1. f1 of 1 is 1 minus j plus w81 is 0.707 minus j 0.707. This complex number will be multiplied by a f2 of 1. f2 of 1 is also 1 minus j. Okay, to simplify this, multiply these two complex numbers, then add it with this complex number 1 minus j, will get 1 minus j 2.414. You calculate it. Okay, you just substitute these values and simplify it, will get 1 minus j 2.414. Okay, likewise, x of 2 will be using f1 of 2 plus w82 f2 of 2. f1 of 2 and f2 of 2 both are zeros. So in the second value, 0 will be multiplied with the 20 factor value minus j, so it becomes 0. So x2 of 2 will be 0. And x of 3 will be f1 of 3 plus w83 f2 of 3. f1 of 3 is 1 plus j plus w83, the fourth 20 factor value is minus 1 by root 2 minus j 1 by 2, or minus 0.707 minus j 0.707 multiplied by 1 plus j, because f2 of 3 is also 1 plus j. Simplify this, we will get 1 minus j 0.414. So the fourth DFT point will be 1 minus j 0.414. So these are the first 4 values of the 8-point DFT. First 4 values of the 8-point DFT, which are obtained as the top point in the butterfly operation. Next, x of 4. x of 4 is the bottom point in the first butterfly structure. So it will be calculated as f1 of 0 minus w80 f2 of 0. Okay, so f1 of 0 is 2, minus 1 into 2. 2 minus 2 will be 0. So fifth DFT point will be equals to 0. Next, x of 5. X of 5 will be 1 f1 of 1 minus w81 because it is the second bottom point in the second butterfly operation. So w8 minus w81 multiplied by f2 of 1. f1 of 1 is 1 minus j minus w81 is 1 by root 2 minus j 1 by root 2 multiplied by 1 minus j. Simplify this, we'll get 1 plus j 0.414. We'll have to get 1 plus j 0.414. Now, which will be the conjugate of x of 3 according to the symmetry property of the DFT. Okay. And likewise, x of 6. X of 6 will be f1 of 2 minus w8 2 f2 of 2. f1 of 2 and f2 of 2 both are zeros, so its value will be 0. And likewise, the last value, 8th DFT point will be f1 of 3 minus w8 3 f2 of 2, which will be 1 plus j minus of minus 1 by root 2 minus j 1 by root 2 multiplied by 1 plus j. Simplify that, it has to be the complex conjugate of the second DFT point, which will be 1 plus j 2.414. 1 plus j 4.4. So 8-point DFT of the 8-point discrete time sequence x of n will be 4 1 minus j 2.414 0 1 minus j 0.414 0 1 plus j 0.414 0 and 1 plus j 2.414. So this is the 8-point DFT of the given 8-point sequence. And if you observe, all the properties of the DFT are satisfied. First DFT point is sum of the samples. There are 4 non-zero values which are 1. So the first DFT point is 4. And all the other values are, half the DFT points are conjugate of the other half. That is the symmetry. अर्थ आएगा? Did you all understand? Any doubts? Any questions? Any doubts? Any questions? Now, which one seemed easier? Computing 8-point DFT by direct method or by using FFT algorithms? Which one is more convenient? Was this procedure easy? Was this procedure easy? Did you all feel this one to be easier? Yes, it is easy, but you need to practice how to draw the signal flow graph. Okay, sometimes connections might not be the way they have to be. Okay, drawing this signal flow graph takes the practice, so you need to practice. Now everything is dependent on the equation. How x of 0 is obtained? We have 2 data points. How it has to be connected depends on whether it is top point on the butterfly or bottom point in the butterfly. And likewise in the subsequent steps. So you follow those 2 equations for DIT FFT algorithm, you will be fine. These will be asked for not less than 10 marks in the weekly examinations. Now let's take one more problem. Compute DFT of the sequence defined by x of n equals to cos n pi divided by 2, cos n pi divided by 2 for capital N equals to 4. For capital N equals to 4 means from this equation we need to obtain 4-point discrete time sequence, and for that 4-point discrete time sequence we need to calculate the 4-point DFT. So substituting small n equals to 0, 1, 2, 3, one value at a time in this expression will give us the discrete time sequence. For n equals to 0, cos of 0 will be equals to 1. For n equals to 1, cos of pi by 2 is 0. For n equals to 2, cos of pi is minus 1. For n equals to 3, cos of 3 pi by 2 is 0. So this is the 4-point sequence for which we need to obtain the 4-point DFT. Here we'll be requiring two twiddle factors because capital N is 4, n by 2 twiddle factors will be used, and those are W40 whose value is equal to 1, which will be equals to W20 as well, and second one W41 which is minus j. Now, how many stages will be in the butterfly? Capital N is 4, it can be expressed as 2 to the power 2, therefore V is equal to 2. There will be only 2 stages. And how many number of decimations? V minus 1, that is 1. One decimation, that is this one 4-point sequence will be decimated into even numbered samples and odd numbered samples. That will give us two 2-point sequences. Because this is ReadyX2 FFT algorithms. In ReadyX2, the smallest decimation has to give us 2-point DFT. That will be given only by a 2-point sequence. Artha agtide? Okay, so let's directly draw this signal flow graph. Now, what has to be the inputs? Inputs will be in the natural order or bit reversed form? Bit reversed form. First sample will be x of 0, which will be equals to 1. Second sample, instead of x of 1, it will be x of 2 because it is bit reversed, whose value is minus 1. And next, x of 1, which is equal to 0, and lastly, x of 3, which is equal to 0 again. Because we are decimating the input, this side will be having 2-point butterfly structures, or butterfly structures which calculate 2-point DFT. And the twiddle factors here will be W40, W40, because we are calculating 4-point DFT. Let's say output of these are V11 of 0, V11 of 1, V12 of 0, V12 of 1. Now I will be writing these values orally by calculating them orally, but you write the expressions for each stage. V11 of 0 will be x of 0 plus W40 multiplied by x of 2. X of 2 is minus 1, so this will be 1. Because of this minus 1, 1 minus 1, 0. Okay. Next, V11 of 1 will be x of 0 minus W40 into x of 2. Because we have already minus side and this data value is also minus, minus of minus will be plus. So V11 of 1 will be 2. Okay, these are the first, these two are the 2-point DFTs. The second 2-point DFTs, to calculate these second 2-point DFT, input values are 0, so their DFT will also be 0. Because 0 plus 0 and 0 minus 0 will become 0. So these are the two 2-point DFTs obtained after the first stage. Later, these two 2-point DFTs are to be combined to get one 4-point DFT, and their butterfly structures will be like this. Minus 1 and minus 1. W4 0 and W4 1. Okay. So let's say this is x of 0. Because input is in the bit reverse form, output DFT will be in the natural order. X of 0, x of 1, x of 2, and x of 2. Now, x of 0 will be V11 of 0 plus W40 multiplied by V12 of 0. Both these data points are 0, so its value will be 0. X of 1 will be V11 of 1 plus W41 multiplied by V12 of 1. V12 of 1 is 0. 0 multiplied by this twin factor, whose value is minus j, will become 0. So we'll retain only V11 of 1, whose value is 2. X of 2 will be V11 of 0 minus W40 multiplied by V12 of 0, which is again 0 because both the DFT points are 0. And lastly, x of 3 will be V11 of 1 minus W41 into V12 of 1, which is 0. So second part will be 0. So we'll retain only 2. This is the 4-point DFT. X of k 0, 2, 0, 2. 0, 2, 0, 2 is the 4-point DFT. 4-point DFT of this sequence. 1, 0, minus 1, 0. Any doubts, any questions? Any doubts, any questions? Okay, if not, let's move on to the last problem. The discrete time sequence is x of n equals to 1, 1, 0, 0, minus 1, minus 1, 0 and 0. This is the 8-point sequence for which we need to calculate the 8-point DFT. Now to write the bit reverse form, use the index values to get the reference what we use. Okay. First data point will be x of 0, whose value is 1. Next data point will be x of 4, whose value is minus 1. Next data point will be x of 2, whose value will be 0. Next data point will be x of 6, whose value is 0. In the bit reverse form. Next data point will be x of 1, whose value is 1. Next will be x of 5, which is minus 1. And last, x of 3 is 0 and x of 7 is also 0. First stage will be having individual butterfly structures. And for every problem you need to start what is B value, how many number of stages will be in the signal flow graph, and how many number of decimations are to be carried out, and what twiddle factors value will be used. You need to mention them, you need to write them for every problem. Because we are used to the two problems are here, I am directly writing them, but you need to mention them. Each of those points carry marks. Okay? Now, the first stage outputs will be V11 of 0, V11 of 1, V12 of 0, V12 of 1, V21 of 0, V21 of 1, V22 of 0, and V22 of 1. So, V11 of 0 will be x of 0 plus W80 multiplied by x of 4. X of 4 is minus 1. 1 minus 1 will become 0. V11 of 1 will be x of 0 minus W80 multiplied by x of 4. Minus of minus will be plus, so this becomes 2. And likewise, x of 2 and x of 6 are 0. So V11 of 0 and V12 of 0 and V12 of 1 will both become 0 because data points are 0. And here they are same as that at the first set of values, so there will be 0 and 2. And the last two values of the 2-point DFT will be 0 because data points are 0. These are the outputs of the first stage. So 2-point DFTs are 0 2 is one 2-point DFT, 0 0 second 2-point DFT, 0 2 third 2-point DFT, and 0 0 fourth 2-point DFT. These 2-point DFTs are to be combined to get 4-point DFTs. And for them, the butterfly structures are this one, not this one, W80 and W82. And like this, the second structure will be repeated. Minus 1, W80 and W82. So F1 of 0, F1 of 1, F1 of 2, F1 of 3, F2 of 0, F2 of 1, F2 of 2, and F2 of 3. The two 4-point DFTs. Okay. Now, F1 of 0 will be 0 plus 0. F1 of 1 will be 2 plus 0. 2. F1 of 2 will be 0 minus 0, 0. And F1 of 3 will be 2 minus 0. 2 minus 0, 2. So, first 4-point DFT is 0 to 0 2. And the same 4-point DFT will be repeated here because the 2-point DFTs that we are combining are same 0 2 0 2. Now these two 4-point DFTs are to be combined in the next stage to obtain 8-point DFT. And that 8-point DFT representation will be shown in the next stage. This is clear. Last time. Total factor values W80, W81, W82, and W83. Okay. And DFT, first DFT, x of 0. X of 0 will be 0 plus 0, 0. X of 1. X of 1 will be 2 multiplied by W81. W81 is 1 by root 2 minus J 1 by root 2 or 0.707 minus J 0.707, for which 2 will be multiplied, which will give us 1.414 minus J 1.414, which has to be subtracted by 2. Which has to be added to 2. So it will be 3.414 minus J 2.414. The DFT point will be 3.414 plus 3.414 minus J 1.414. And likewise, x of 2 will be 0 plus 0, so 0. X of 3 will be F1 of 3 multiplied plus W83 multiplied by F2 of 3. Here 2 multiplied by minus 1 by root 2 minus j 1 by root 2. It will be minus 1.414 minus j 1.414, from which 2 has to be subtracted. Okay, because 2 has to be added. So it will be 2 has to be subtracted. 2 minus 2.414 will be 0.414 minus j 1.414. So the fourth DFT point will be, sorry, it has to be 0.586. 0.586 minus j 1.414. And the next value, x of 4 will be 0 minus 0, 0. X of 5 will be conjugate. It will be actually 2 minus W81 multiplied by 2. W81 is 0.707 minus J 0.707. It has to be conjugate of 0.586 minus J, or because of conjugate it will be plus 1, plus J 1.414. Next, x of 6 will again be 0 minus 0, whose value will be 0. And last value, x of 7 will be conjugate of this second term, which will be 3.414 plus j 1.414. So this is the 8-point DFT. 8-point DFT of this given discrete time sequence x of n 1 1 0 0 minus 1 minus 1 0 0. Any doubts? Any questions? Any doubts? Any questions? Did you all understand the procedure of decimation in time fast Fourier transform and the problems that we solved on decimation in time fast Fourier transform? Artha agide? Everything is dependent on only two equations of one butterfly structure. If you get those two equations, then you can develop the signal flow graph very easily. Okay. Now in the next class, we'll be starting with the second classification in radiance-2 algorithm, that is DIF FFT algorithm, which stands for decimation in frequency fast Fourier transform, which is exactly the reverse of this. Now, what are the methodologies? What will be? How will be developing the signal flow graph? We'll be going through in the next class. Okay. Any doubts? Any questions?